Welcome to Astro Odyssey. Explore the universe. Tonight, we begin with a question that doesn't announce itself loudly. It doesn't demand attention. It simply lingers, waiting to be noticed. A question that has quietly followed astronomers for decades. One that reshapes everything we believe about planets, stars, and life itself. How rare is the solar system we call home? Not just uncommon, not just statistically unusual, but possibly so extraordinary that finding another one, like it may be nearly impossible, as the visuals drift across distant stars and silent nebulae. There is no pressure to stay alert. Let your eyes rest if they wish. Let your breathing slow, because sometimes the deepest truths of the universe reveal themselves not through effort, but through stillness. Asterisk, somewhere on Earth it's night. Somewhere else, dawn is breaking. And somewhere else still, the sun hangs quietly in the sky. Yet despite our distances, we are all standing on the same fragile world. A thin layer of atmosphere, a spinning sphere of rock and water. Suspended in darkness, every human who has ever lived, every story, every dream, every fear has unfolded right here, tonight. As we talk about the rarity of our solar system, we do so from within it. From a single, improbable point in the vast cosmic ocean. Asterisk, imagine a place that exists only in thought. A cosmic library. Its shelves stretch endlessly, disappearing into the dark. Each book contains the complete story of a planetary system somewhere in the Milky Way. Billions of stars. Billions of families of worlds. As you move through this library, patterns emerge. Many systems look familiar. Large planets close to their stars, chaotic orbits, worlds packed tightly together. These are the common stories. But then, tucked away on a quiet shelf, you notice something different? A single book that feels out of place. Its pages describe a system with wide, calm spacing. Small, rocky planets near the star. Massive giants far away. Balanced, stable, patient. That book tells the story of our solar system, and unlike every other story in this library, we are not merely readers. We are characters inside it. Asterisk, each morning, the sun rises without drama. It asks nothing of us. It simply appears. But this quiet reliability hides something extraordinary. Our sun belongs to a rare group of stars known as yellow dwarfs. Only about 10% of stars in our galaxy share this classification. Most stars are red dwarfs, smaller, cooler, and far more volatile. They flare violently. They bathe nearby planets in radiation. Life around them faces enormous challenges. But our sun burns steadily. Not too hot, not too cold. For billions of years, it has provided a consistent energy source, the kind needed for oceans to remain liquid, for chemistry to slowly become biology, and for complexity to take its time. Asterisk, there's something else that makes our sun unusual. It contains an unexpectedly high amount of heavy elements. What astronomers call metals. This detail may sound small, but without it, Earth would not exist. These elements allowed rocky planets to form. They became mountains, oceans, magnetic fields. Some evidence suggests our sun may have formed elsewhere in the galaxy and later migrated to its current position, carrying with it a chemical richness that made everything else possible. Asterisk, as we move outward from the sun, a rare pattern reveals itself. For small, rocky worlds close in. For massive giants far away. This isn't common. In fact, it's the rarest planetary architecture scientists have identified. Less than 1% of known systems display this kind of order. Most planetary families are. Messy, crowded, unstable, but ours is spacious, deliberate, calm. This orderly structure plays a critical role in long-term stability, and without it, life would struggle to survive. Asterisk. Look closely at the paths our planets follow. They are nearly circular, predictable, unchanging over immense spans of time. This is astonishing. Most systems bear scars of violence. Planets thrown into wild orbits, worlds ejected into interstellar space. Our solar system avoided this fate. For more than 4.5 billion years, its planets have danced in harmony. This kind of stability is not guaranteed. It is earned through extraordinary timing and balance. Asterisk. Jupiter is massive. So massive that it could have ended everything. In the early days of our solar system, Jupiter migrated inward toward the Sun. Had it continued, it would have scattered the material needed to form Earth. But something remarkable happened. Jupiter reversed course. Pulled outward by Saturn, it reshaped the entire system, clearing excess material, preventing the formation of destructive super-Earths. This single event may be the reason Earth exists at all. Asterisk. The timing had to be exact. Too early, no Earth. Too late, no stable orbit. The window for success was narrow. And yet, somehow, the solar system passed through it perfectly. Asterisk. Across the galaxy, astronomers keep finding the same type of world. Mini-Nep. Larger than Earth. Smaller than Neptune. Incredibly common. Yet our solar system has none. There is a sharp gap between Earth and Neptune, an absence that speaks volumes. Something prevented those worlds from forming here. That something was likely Jupiter. Once again, protection through destruction. Asterisk. Between Mars and Jupiter lies a broken world that never was. The asteroid belt, in many systems. This region becomes another planet. Here, Jupiter's gravity prevented it. What remains is debris. It's a record of early chaos. But this failure became a gift. The asteroid belt absorbs impacts, shielding the inner planets from constant bombardment. Another unlikely benefit of an unlikely arrangement. Asterisk. Most stars are not alone. They orbit companions, sometimes two. Sometimes more. These systems are unstable places for planets. But our sun travels solo. No companion star to disturb planetary orbits. No violent gravitational interactions. Its solitude allowed calm to emerge, and calm allowed life to grow. Asterisk. And yet, we've only scratched the surface. We haven't spoken about the moon, about Earth's perfect orbit, about our quiet place in the galaxy. Each layer adds another improbability. Each coincidence compounds the mystery. Asterisk. When night falls and the sun disappears, another presence takes over the sky, silent, steady, unchanging. The moon. It has watched over Earth for as long as the Earth has existed in anything close to its current form. But this quiet companion is far more unusual than it appears. Among rocky planets, large moons are rare. Extremely rare. Most planets have no moons at all. Some have tiny ones, barely more than captured rubble. But Earth's moon is different. It is enormous compared to its planet. So large that some scientists argue Earth and the moon form a double planet system. Asterisk. The moon did not form gently. It was born from violence. Very early in Earth's history, a Mars-sized world collided with the young planet. This impact should have destroyed everything, but it did. Instead, the collision occurred at exactly the right angle, at exactly the right speed, at exactly the right moment in Earth's formation to direct, and Earth would have shattered. Too shallow, and the debris would have escaped into space. Too early, and the planet wouldn't survive. Too late, and the moon would never form. Yet somehow all conditions aligned from the debris. The moon slowly assembled, a cosmic accident that behaved like a miracle. Asterisk, without the moon, Earth would not be the world we know. Its gravitational pull creates tides, a rhythmic rise and fall of the oceans. These tides do more than move water. They stir the seas. They prevent stagnation. They redistribute heat and nutrients, some scientists believe. Tidal zones may have helped. Early life transitioned from water to land, but the moon's most important role is quieter. It stabilizes. Earth's tilt, asterisk, Earth is tilted slightly as it spins. This tilt gives us seasons, but without the moon, that tilt would wobble wildly. Look at Mars without a large moon. Its tilt swings dramatically over millions of years. It's from mild to extreme. Such instability creates violent climate shifts, ice ages, global deserts, sudden collapses. Earth avoids this chaos because the moon acts like a stabilizing anchor, holding Earth steady, keeping climates predictable, allowing life to plan, adapt, and evolve. Asterisk, even the moon's orbit matters. It's not too close. Where tides would tear Earth's crust apart, not too far. Where its stabilizing influence would fade, it orbits in a nearly circular path, creating consistent tidal rhythms, enough motion to energize the planet, not enough to destroy it. Another narrow window, another perfect alignment. Asterisk, Earth doesn't just sit in the habitable zone. It stays there. Its orbit around the sun is nearly circular. This is unusual. Many planets follow elongated paths, swinging between freezing distance and scorching proximity. Earth doesn't. Temperatures remain relatively stable. Year-round seasons change, but extremes are avoided. This stability allowed oceans to persist for billions of years, and oceans are patient teachers. Asterisk. Earth's calm orbit is not accidental. It is shaped by the entire solar system, the spacing of planets, their masses, their gravitational relationships. Jupiter plays a key role. Its immense gravity prevents Earth's orbit from becoming too elliptical. Without Jupiter, Earth's path could stretch dangerously, pushing the planet in and out of the habitable zone. Life would struggle to survive such swings. Asterisk. Earth has something many planets lose early, strong magnetic field, generated deep within the planet by deep molten iron moving in the core. This invisible shield deflects solar wind, streams of charged particles constantly flowing from the sun. Without it, Earth's atmosphere would slowly be stripped away. This happened to Mars. Its magnetic field faded. Its atmosphere thinned. Its water disappeared. Earth endured because its size, composition, rotation, and internal heat all aligned. Another fragile balance, held for billions of years. Asterisk. Earth didn't form wet. The early inner solar system was dry and hostile. Water arrived later, likely delivered by asteroids, and comets nudged inward by the gravitational movements of the giant planets. This delivery had to happen. At the right time, too early, water would be lost to space. Too late, life may never begin. The timing appears nearly perfect. Enough water to fill oceans, not so much that Earth becomes a global ocean world. Asterisk, roughly 4 billion years ago. The inner solar system endured a violent period. Asteroids and comets rained down. This era, known as the Late Heavy Bombardment, sounds catastrophic, and it was. But it may also have been essential. These impacts delivered water, organic compounds, and energy. They reshaped the surface, mixed chemistry, created niches. The bombardment ended just as life began to gain a foothold. Too early sterilization, too late extinction. Once again, timing mattered. Asterisks zoom out farther, beyond planets. Beyond the sun, our solar system sits in a rare galactic location, far from the violent center of the Milky Way, yet not too far out. Where heavy elements are scarce, we orbit between spiral arms, a quieter region with fewer supernova. Explosions can strip atmospheres from nearby planets. We've avoided them, not by chance, but by location and timing. Asterisk. The sun orbits the galaxy once every 250 million years. During that journey, it passes through different environments. Some are dangerous. Some are calm. Life on Earth emerged during a quiet stretch had we formed earlier. The galaxy lacked heavy elements had we formed later. The neighborhood may have been too crowded. Once again, the window was narrow. Asterisk at this point. The pattern becomes hard to ignore. Every requirement for life has had a margin for error, and that margin was small. Miss one condition, the moon. The orbit, the timing, the location, and Earth becomes unrecognizable. Yet all conditions aligned, not just once, but repeatedly. Across billions of years, asterisk, as you rest here now, breathing quietly, listening to this story unfold, remember where you are. On a planet stabilized by a moon that should not exist, orbiting a star that burns calmly when most do not, in a galaxy that briefly made space for peace. You are not separate from this story. You are its continuation, asterisk. But there is still more. We haven't explored the outer solar system, the Kuiper Belt, the protective giants, the invisible shields surrounding us, asterisk now. Let your awareness drift beyond Earth, past the moon, past Mars, beyond the warm inner worlds, into the colder reaches of our solar system. Here sunlight weakens, temperatures fall, and massive worlds begin to dominate the architecture of everything. This is where the giants live, asterisk. Jupiter is enormous, more massive than all the other planets combined. Its gravity shapes the entire solar system. In many systems, a planet like Jupiter spells disaster. It migrates inward, becoming a hot Jupiter, a massive world that scorches everything close to the star. But Jupiter didn't do that. Instead, it stopped. It settled far from the sun, exactly where a guardian would need to be. Asterisk. Jupiter's gravity does something remarkable. It captures or deflects countless asteroids and comets. Some are flung out of the solar system entirely. Others are absorbed. Others are redirected into safer paths. Without Jupiter, Earth would experience far more catastrophic impacts. Life would reset again and again. Complex ecosystems might never stabilize. Jupiter is not gentle, but it is protective. Asterisk. Beyond Jupiter lies Saturn. Graceful, ringed, immense. Saturn's role is quieter, but equally vital. Its gravity helped shape Jupiter's final position together. These two giants entered a near-perfect orbital relationship, a near 2-to-1 resonance. For every 2 orbits, Jupiter completes. Saturn completes almost 1. This resonance is not accidental. It represents a gravitational compromise, a balance that promotes long-term stability instead of chaos. Asterisk. In most planetary systems, resonances lead to instability. Planets tug on one another until orbits collapse. But in our system, resonance became harmony. It prevented violent migrations. It stabilized the inner worlds. It allowed calm to persist for billions of years. This outcome is rare. Computer. Simulations suggest most systems fail here. Ours did not. Asterisk farther still. Two quieter giants orbit in the cold. Uranus and Neptune. They are often overlooked, but their influence is profound. Early in the solar system's history, these planets migrated outward. Their movement reshaped the outer solar system, clearing debris, defining boundaries, organizing chaos. Most systems don't survive this phase intact. Planets are ejected. Orbits collapse. But somehow, the inner worlds remained untouched. Asterisk beyond Neptune lies the Kuiper Belt, a vast region filled with icy remnants, frozen leftovers from the birth of the solar system. In many systems, this region is destroyed, scattered, or erased by violent migration. But ours survived. The Kuiper Belt preserves ancient materials exactly as they formed billions of years ago. It is a record of cosmic memory, a place where time slowed down. Asterisk planetary formation is usually violent collisions, ejections, extreme mixing. Preservation requires gentleness. Our system somehow achieved both. Enough violence to shape structure, enough calm to preserve history. This balance is almost never observed elsewhere. Asterisk, return inward. Again, between Mars and Jupiter lies the asteroid belt. Not random debris, but carefully constrained debris, too little gravity, and asteroids would scatter inward. Too much, and they would be cleared entirely. Instead, they remain trapped, serving as both shield and archive. Another narrow window. Another unlikely success. Asterisk beyond planets. Beyond debris, beyond even light. There is another protector, the heliosphere, a vast magnetic bubble. Created by the sun's solar wind, it surrounds the entire solar system, shielding us from high-energy cosmic radiation. Asterisk. Outside this bubble, space is hostile. Charged particles move at near light speed. They damage DNA, strip a thirst. The heliosphere weakens these particles. Not completely, but enough. Enough to allow life to persist. The size and strength of this bubble depend on the sun's stability. Many stars fail here. Ours did not. Asterisk over billions of years. Stars change. They brighten. They flare. They destabilize. Our sun has aged slowly. Its luminosity increased at a rate Earth could adapt to. Its magnetic cycles remained balanced. No prolonged flaring. No sterilizing radiation storms. This kind of stellar temperament is rare. Asterisk. Every planet contributes to a complex electromagnetic environment. Magnetic fields interact. Solar wind flows, bend, and shift. Together, they create a stable space weather system. Auroras dance. Atmospheres remain intact. This electromagnetic harmony is delicate. Many systems lose it early. Ours maintained it. Asterisk. Life doesn't just need the right conditions. It needs time, billions of years without catastrophe, without orbital collapse, without atmospheric loss, without constant resets. Our solar system delivered that time, quietly, patiently, against overwhelming odds. Asterisk by now. A pattern is undeniable. Each layer of protection depends on another. Remove one piece, the Moon, Jupiter, Saturn, the heliosphere, and the system destabilizes. This is not redundancy. It is interdependence. A system built from cooperation, not isolation. Asterisk, as you listen. Notice your breath slow, steady. Your body depends on oxygen, pressure, temperature. Each of those depends on this cosmic structure. You are breathing because the solar system works. But there is still another mystery. The chemistry. The elements. The ancient stellar deaths that made Earth possible. Asterisk long before the sun existed. Before planets, oceans, or even atoms like those in your body. There were other stars. Massive, short-lived, violent. They lived fast and died spectacularly. And in their deaths, they made everything else possible. Asterisk, the earliest stars in the universe were simple. They burned hydrogen. They burned helium, but they produced almost nothing else. Without heavier elements, rocky planets cannot form. No iron, no silicon. No oxygen-rich minerals, no Earth. Asterisk, inside massive stars, nuclear furnaces burn, hydrogen fuses into helium, helium into carbon, carbon into oxygen. Layer by layer, heavier elements are built, until the star can no longer hold itself together. Then, collapse. Then explosion. A supernova. Asterisk supernova. Scatter elements across space. Iron, gold, uranium, carbon. Everything. Heavier than helium was forged in stars that died. The calcium in your bones. The iron in your blood. The oxygen you breathe, all of it began in stellar death. Asterisk. But not just any mixture will do. Too many radioactive elements and planets become unstable. Too few, and they cool too quickly. Our solar system formed from material, enriched by multiple stellar deaths. Not one, not too many, just enough. This balance is astonishingly precise. Asterisk. Gold doesn't come from ordinary Cerno. It comes from collisions of neutron stars. Events so rare and violent, they warp space itself. Somewhere, billions of years ago, two neutron stars collided. Their debris drifted for eons, and eventually, traces of that gold ended up here. Not enough to poison Earth, enough to enrich it. Asterisk. Some elements decay slowly. Uranium, thorium, potassium. Their decay releases heat. This heat drives plate tectonics, volcanism, magnetic fields. Without it, Earth would be geologically dead, but radioactive heat must be carefully balanced. Too much deadly radiation. Too little frozen interiors. Earth received just the right amount. Asterisk. Earth is active. Its crust moves. Its mantle flows. Its core spins. This internal motion powers the magnetic field that shields life from radiation. Many planets lose this early. Mars did. Earth did not, because its composition was just right. Asterisk. Water is simple. 2 hydrogen atoms. 1 oxygen, but liquid water is rare. It requires temperature, stability, pressure. Gravity. Earth maintains all 3. Water dissolves chemicals, transports energy, encourages complexity. Life depends on this solvent. Asterisk. Carbon forms chains, long ones, complex ones. It creates the backbone of biology. But carbon must exist in the right chemical environment. Too much oxygen, it burns. Too little chemistry stagnates. Earth's atmosphere walked a narrow path, allowing carbon, chemistry, to flourish. Asterisk. Earth's atmosphere evolved slowly. Early gases escaped. Volcanic gases accumulated. Oxygen rose gradually. Too fast, life would fail. Too slow, complexity never emerges. This process took billions of years, and it never reset catastrophically. Asterisk plate tectonics recycle carbon. Carbon enters rocks. Rocks subduct. Volcanoes release gas. This cycle regulates climate, prevents runaway greenhouse effects, prevents global freezing. Venus lost this system. Earth kept it. Again, chemistry, size, heat, and timing aligned asterisk Matthias fall to Earth. They carry ancient signatures, isotopes that reveal formation temperatures, distances from the sun, chemical histories. These records show surprising order, little mixing, little chaos. Our system formed gently. Asterisk most planetary systems form in chaos. Young stars cluster tightly. Radiation strips disks. Close encounters disrupt orbits. Our sun formed in a quieter region, far enough from danger, close enough for enrichment. Another narrow window. Asterisk timing appears again and again. Stellar deaths. Solar formation. Planetary assembly. Too early. No heavy elements. Too late. Overcrowded space. Our sun was born at the right cosmic moment. Asterisk. Every atom in your body has a history older than Earth. Some were born in dying stars. Some in ancient collisions. They traveled for billions of years before becoming you. That journey required stability. It required this solar system. Asterisk. As you breathe, your lungs fill with oxygen forged in stars. Your heartbeat moves iron. Through your blood, your thoughts rely on chemical reactions that depend on precise physical constants. You are not separate from the cosmos. You are a continuation of it. But chemistry alone is not enough. Life needs stability over unimaginable spans of time. Asterisk life doesn't just need the right ingredients. It doesn't just need water, chemistry, or energy. It needs something far rarer. Time. Not thousands of years. Not millions, billions. Time without collapse. Time without constant catastrophe. Time without being erased again and again. Most planetary systems never receive this gift. Asterisk the universe is not gentle by default. Stars explode. Planets collide. Orbits unravel. Young planetary systems are chaotic places. Worlds migrate inward. They crash into one another. They are flung into interstellar space. Stability is the exception, not the rule. Asterisk in many systems. Large planets move too much. They drift inward and outward, dragging smaller worlds with them. This movement destabilizes everything. Orbits cross. Collisions follow. Order dissolves. Our solar system avoided this. Fate, not because it had fewer forces, but because those forces balanced. Asterisk Earth has followed nearly the same path for over 4 billion years, that is. Astonishing tiny changes compound over time. A small disturbance today becomes a catastrophe in a million years, yet Earth's orbit remained calm. This required continuous correction, a quiet gravitational conversation between planets that never escalated into violence. Asterisk planets don't just pull on one another. They communicate. Through resonance, through timing, through distance, each orbit adjusts slightly to maintain harmony, like dancers sensing one another's movements. Most systems fail to find this rhythm. Ours did. Asterisk computer simulations reveal a sobering truth? Run planetary formation 1,000 times. Most outcomes end in destruction. Only a few results in stable, Arrangements, fewer still remain. Stable for billions of years, our system landed. In that narrow outcome space, not once, but continuously. Early Earth was hostile. Volcanoes, radiation, impacts, but time smoothed the extremes. Chemistry experimented, molecules formed, broke apart, reformed, over and over. Without time. Complexity cannot accumulate. Without stability. Learning resets. Earth avoided both traps. Life did not appear suddenly. It crept. Simple molecules became complex ones. Complex ones form networks. Networks learn to copy themselves. Each step fragile. Each mistake fatal. Only patience made it possible. Earth experienced mass extinctions, but none ended everything. This matters. Total. Sterilization resets the clock. Earth never fully reset. Even the worst events left survivors. Why? Because impacts were moderated. Radiation was buffered. Atmospheres remained intact. Protection layered upon protection. Jupiter didn't eliminate impacts. It regulated them. It redirected danger without eliminating delivery. Water arrived. Organics arrived, but not endlessly. This balance allowed recovery. Too much protection, no ingredients. Too little, constant destruction. Once again, the middle path prevailed. Stars change over time. They flare. They pulse. They destabilize. Our sun has been unusually calm. Its energy output increased. Gradually, Earth adapted. Oceans regulated temperature. Atmospheres compensated had the sun brightened faster. Oceans would have boiled had it dimmed. Earth would have frozen. Neither happened. Earth has feedback systems. Warming increases cloud cover. Clouds reflect sunlight. Cooling follows. Cooling reduces clouds. Sunlight warms the planet again. These loops stabilize climate, but they require time to develop. They require continuity. Earth had both. Nothing dramatic happened for millions of years at a time. No planet-shattering collisions. No orbital collapse. This silence is not boring. It is essential. Complexity grows quietly. Water is common in the universe. Time is not. Uninterrupted time. Not protected time. Most systems are interrupted. Earth was allowed to continue. Life stores information, DNA. Remembers what worked, but memory requires continuity. Erase. The system memory is lost. Earth preserved its memory, generation after generation, mistake after mistake, success after success. Earth was never hurried. It took billions of years to grow forests, hundreds of millions. To develop complex animals, this pace required safety. The universe rarely provides it. As you listen now. You are surrounded by patience. The air has been breathable for longer than humanity existed. The oceans have flowed since. Before bones formed, this stability is not ordinary. It is rare beyond words. You exist. Because nothing reset the clock. Because no catastrophe erased everything. Because the solar system held. Again and again. And again, But there is still one final layer, the most subtle one. The laws of physics themselves. Asterisk up to now. We've talked about stars, planets, moons, timing, stability. But beneath all of that, there is something even more fundamental. Something we almost never notice. The rules themselves, asterisk, every orbit, every atom, every reaction, all of it follows laws, not suggestions. Not tendencies laws. Gravity behaves the same everywhere. Electromagnetism never forgets its rules. Quantum mechanics governs the smallest scales with relentless precision, and those laws are balanced on a knife's edge. Asterisk stars would burn too fast. They would collapse early. They would explode violently. Planets would spiral inward, or never form at all. Time would disappear. Life would never have a chance. Asterisk stars would never ignite. No fusion. No sunlight. No chemistry beyond hydrogen. A universe filled with darkness and gas, stillness without complexity. Asterisk. Electromagnetism binds atoms together. It allows electrons to orbit nuclei. It defines chemistry. Change it slightly, and molecules fall apart. Water would not exist. Carbon chains would collapse. No biology. No memory. No thought. Asterisk light moves at a specific speed, not faster, not slower. That speed defines causality. It determines how stars burn, how energy spreads, how information flows, alter it, and the universe becomes unrecognizable. Asterisk at the smallest scales, nothing is perfectly predictable. Particles flicker in and out of existence. This uncertainty allows stars to ignite. Without it, fusion would stall. The universe would be cold and dark. Even randomness has a role. Asterisk. Physicists have identified dozens of fundamental constants. Each one has a specific value. Together, they allow complexity. Change any one, even slightly, and stars, planets, chemistry, and time collapse. The range for success is unimaginably narrow. Asterisk. Most possible universes, if the constants vary, are sterile. No stars, no planets, no observers. The universe we inhabit is not average. It is special. Asterisk, why these values? Why this balance? Why a universe that allows systems like ours? Science does not yet have an answer, and perhaps never will. Asterisk. One way to think about it is like a lottery with infinite tickets. Almost all are blank. One allows complexity, and somehow, this universe drew that ticket. Asterisk, from those constants came gravity, from gravity came stars, from stars came elements, from elements came planets, from planets came oceans, from oceans came life, from life came awareness, a chain unbroken, each step dependent on the previous. Asterisk, when viewed as a whole, our solar system appears almost impossible. Not because of one factor, but because of all of them together. Physics allowed stars. Chemistry allowed planets. Time allowed evolution. Stability allowed memory. Remove any layer in the entire structure collapses. Asterisk. Your existence is not separate from this story. You are proof that the chain held, that nothing broke, that the universe remained patient, long enough for consciousness to awaken. Asterisk, you are not standing in the universe. You are something the universe is doing, a way for matter to notice itself. Asterisk, across billions of galaxies. There may be countless stars, but awareness is fragile. It requires everything to work. You are experiencing one of the rarest outcomes possible. Asterisk, not sacred in a mystical sense, sacred. In a statistical sense, a convergence so unlikely that it may never repeat. A structure so delicate that it survived only once. Asterisk. Pause here. Feel the weight of that realization. Not fear, not pride, just wonder. Asterisk. The universe did not promise meaning. It promised laws. And within those laws, meaning emerged briefly, quietly. Here, asterisk, every night. Sky you've ever seen was made possible by this chain. Every breath, every memory, you are not small, you are improbable. Asterisk will bring everything together. The rarity, the beauty, the responsibility, and will return gently to where we began. Asterisk. Now, gently, we return to the beginning, to the quiet question that started everything. How rare is the solar system we call home? After everything we've explored, the stars, the planets, the timing, the laws, the answer feels different now. Heavier, deeper. Asterisk. Our solar system is not merely uncommon. It is not simply one variation among many. It represents a convergence of circumstances so precise, so interdependent, that removing any single thread would unravel the whole. A rare star, an ordered planetary layout, protective giants, a stabilizing moon, a quiet galactic neighborhood. Billions of uninterrupted years, each alone is unlikely. Together, they approach impossibility. Asterisk. Some people worry that rarity makes existence lonely, but rarity does not mean insignificance. Diamonds are rare. Masterpieces are rare. Moments of true stillness are rare. Rarity is not emptiness. It is value. Asterisk. The universe took its time. Nearly 14 billion years passed before conditions aligned just right. Stars were born and died. Galaxies evolved. Elements scattered and mixed. And only then, only here, did a world awaken. Asterisk. Our solar system did something extraordinary. It stayed calm, while others collapsed. While others scattered, it held. Orbit after orbit, age after age. Quiet success rarely makes headlines, but it makes life possible. Asterisk. Earth is not magic. It is a consequence, a result of physics behaving consistently, of chemistry following rules, of time being generous, yet the outcome still feels miraculous, because consequences this delicate almost never survive. Asterisk. You are not separate from the solar system. Your bones contain calcium forged in stars. Your blood carries iron from ancient explosions. Your breath moves molecules shaped by planetary gravity. Your thoughts arise because this system never fell apart. Asterisk. The universe did not announce consciousness. It didn't arrive with thunder. It arrived softly, in chemical reactions, in neural sparks, in awareness slowly opening its eyes. And now, the universe can reflect on itself through you. Asterisk. Rarity does not demand fear. It asks care. If something is rare, it is not meant to be wasted. If something is fragile, it is meant to be protected. This solar system endured chaos to make room for awareness. What we do with that awareness matters. Asterisk. Earth is not just a planet. It is a safe harbor in a hostile sea. A small, warm island in a vast cosmic night. And it has carried us patiently without complaint. Asterisk. The next time you look at the stars, remember what you're seeing. Not infinite abundance, but survival. Each star, a possibility. Each system, a gamble. And this one, your home, a quiet winner. Asterisk. You don't need to feel awe. You don't need to feel small, just present, breathing air that has existed for eons, resting on ground shaped by ancient forces, alive during a calm chapter of cosmic history. Asterisk. This story is not about superiority. It is about perspective, understanding. How rare stability is changes how we treat it, how we treat Earth, how we treat each other, how we treat time. Asterisk. As you drift toward rest, let this understanding soften you. Let it quiet unnecessary urgency. You are here because patience won. Asterisk. Somewhere in the galaxy, countless stars burn. Most will never host life. Most will never know stillness. But here on this small world within this rare solar system, the universe learned to pause. And in that pause, you exist. Asterisk. So rest now. You are held by a system that has endured for billions of years. You are safe within one of the rarest arrangements the universe has ever formed. Good night.
Asterisk.